Hello friends, today in this particular video I will be telling you how to differentiate a polynomial function using Numpy, and after differentiation what will be the value of that particular differentiated polynomial for a particular value of x. So first thing first, we'll be importing Numpy. Once this is imported, we will be using a function called as polydir to differentiate the polynomial and polyval to evaluate the value of the polynomial. The most important part um, for this differentiation using NumPy is to create a polynomial array. That means the array of coefficients of the polynomial. So I have taken two examples. One by one I'll be doing this. So first example first. So let's create a function fn1, that is a function having coefficients, or the array having coefficients of the function. So this is my fn1. So array, and then I will be passing the coefficients starting from the highest degree, that is 3. So this will be 1. Then this is having coefficient, x square is having coefficient -5. Then this x is having coefficient 4, and then this constant 10. Now you can very well appreciate the fact that this is of degree 3, and we have created an array having 4 uh, objects in it. So the starting point of the array should be the coefficient of the highest power of x, and then in the reduction order, in the reducing order. Now I want to differentiate this and save the result to, let's say, DIF. Then I will be using polydir function and passing the array of the coefficients. So this will be returning me the coefficients of the polynomial which we will be getting after differentiation. And as this is of degree 3, so the degree of the differentiated polynomial will be 2. So that array will be having 3 coefficients. So let me print this also. So now you can see, if you differentiate x cube, you will be getting 3x square. So 3 is there. On differentiating this x square, this becomes 2x. So -5 into 2 becomes -10. On differentiating 4, it becomes 4x. It becomes x. It becomes, sorry, 4. So 4 is there, and this is a constant. So differentiation will be 0. So this becomes a polynomial of order of degree 2. Now to evaluate the value of this polynomial at certain x, so we'll be using polyval function, which will be taking this polynomial, that is differentiated one, DIF, and I am interested in knowing the value when x is equal to 1. So the value of differentiation of the original polynomial at x is equal to 1 will be 3 minus 10, sorry, will be -3. Now there is another problem where the degree is 3, but this x square coefficient is not there. So the purpose of showing this particular example is because the setting up of the array for differentiation is very much important. So let me copy the original one, and now look, this particular function doesn't have any x square term. So the coefficient which is attached to x square should be kept as 0. Remember, the degree, whatsoever the degree of the polynomial will be, the array will be containing that degree plus 1 number of terms, and the coefficient should be kept accordingly. So here the coefficient of x cube is 1, the coefficient of x square is 0, so we have kept as 0, and then comes the 4, and then comes n. Then the same procedure, let us say DIF1 assigned polydir of this function 1, and if you print this DIF1, you will be getting 3, 0, and 4. That what you should get. That is 3x square plus 0 x plus 4. And once you wanted to know the value, you will be using polyval function. So polyval, passing the polynomial whose value you want to know. Let's say I'm interested in knowing the value of this polynomial at x is equal to 1. So that's it, 7. So 7 will be the value of differentiation of this polynomial when x is equal to 1. So in this way, you can use NumPy for the evaluation of differentiation or for differentiating a polynomial and then getting the value of that polynomial a certain value of x. Thank you very much for watching the video. Take care.